Now we'll study about mutual induction. As you already studied about self-induction, which gives us a property of a coil or a conductor due to which it opposes change in current in itself. Now if we talk about mutual induction, let us write down about it. It is a property of a pair of coils. Always remember that mutual induction is defined for a pair of coils due to which change in current in one coil is opposed by the EMF induced in other coil. This is the only difference between self-induction and mutual induction, that self-induction is a property by which change in current in one coil is opposed by the EMF induced in itself. But mutual induction we define for a pair of coils, and for a pair of coils we can see that one change in current in one coil is opposed by the EMF induced in the other coil. This phenomena is called mutual induction. Let's consider a situation when we are given with a coil and nearby another coil is placed, and say if a current I1 flows in the first coil, due to which say a magnetic induction is produced in it, and that magnetic induction produces a magnetic flux phi1 in the first coil. As the second coil is placed nearby, a part of this flux phi1 will also pass through the second coil and it will be linked with all the turns of the second coil. If I1 increases, we can say phi1 increases, then the flux which is linked with the second coil, which is phi2, this will also increase. And if flux passing through the second coil increases and EMF will be induced E2 in the second coil, say we name this coil as 1, this coil is 2. And due to E2, for the circuit with which the coil is connected, a current I2 starts flowing. I2 may be in any direction. Depending on this direction, we can say a magnetic flux will also be developed in the second coil, and it should be in such a direction that it will oppose the cause of induction, which is the change in the flux of first coil, or indirectly the change in current in first coil. So here we can say as the flux is increasing toward rightward direction, the current I2 will be induced in such a way that it will produce a magnetic flux in opposite direction. And this magnetic flux will oppose this phi1. Indirectly we can say this magnetic flux will affect the EMF induced in the first coil, or the increment in the first coil current will be opposed by this flux which is produced by the current in second coil. And also remember, the current in second coil was indirectly induced by change in I1. You must take a proper review of this lecture at least 2-3 times till you understand the actual concept of mutual induction. I'll write it once again. Here we can write, if I1 changes, this implies phi1 changes, this implies an EMF is induced in coil 2. I1 was the current in first coil, phi1 was the flux in first coil. Due to the change in phi1, a part of it which was linked with the second coil changes and it induces an EMF in second coil. We can write due to which a current is induced in coil 2 and its direction is such that it opposes the cause of induction, and the basic cause of this induction is change in I1. So we can say its direction is such that it opposes the change in current I1. This is the whole phenomena which Concept wise, we can simply call mutual induction. Mathematically, the concept we are going to study from the next topic.